Hello, nice to have you on the stage. Yeah, great. So Gregor is with JOANNEUM Research, and he'll be telling us about sensor systems based on electro-active polymers, highly integrated and tailor-made ones. So when you're ready, please share your slides.
So thank you for the invitation and the introduction. And yeah, my talk is, I think, in some areas pretty similar to the talk before, as I also will give an introduction on piezoelectric polymers in this case, so no ceramics, and just an overview of this work we currently carry out at JOANNEUM Research. And here in the first slide, also just a rough or short overview regarding JOANNEUM Research. I think it can be described as the Austrian Fraunhofer agency, so similar to Fraunhofer in Germany. We are a non-profit research organization, about 500 employees in 6 locations, the second largest in Austria, and divided into 7 research units, and I'm representing the Department of Materials. And in this department, we, over the last, now it's about 14 years, we have developed, and I think many of you might already know this technology, the BISOFLEX technology, which we regard as a superordinate technology in the field of printed electroactive polymers. And we see a huge potential in many different fields of application, like shown here in the field of health and well-being, in smart city, smart living, also the field of smart mobility or consumer electronics. But basically, and on the feedback and cooperations ongoing with companies, we see the energy harvesting as some high potential field of application, as well as industrial sensing. So for pressure distribution monitoring, condition monitoring, also access control. So all use cases shown here. And basically, the BISOFLEX technology can be seen as a solution which, on the one hand, can equip existing surfaces or products with additional functionality, and so create sort of an added value. And yeah, BISOFLEX basically means it's an acronym formed of bioelectricity. So it's the ability of the sensing material to detect changes in temperature, which enables like motion control or touchless interaction, which is since a few years to be seen as a side topic, as we really focus on the piezoelectric effect. And here you see at low frequencies, it's of course like a HMI, so touch input, and which is also quite a nice feature of the material is in high frequencies, you can use it for vibration monitoring. So structure-borne sound, if applied into stiff surfaces, like it's when you drop a stone in the water, the acoustic waves can be easily detected by this device, as it is really sensitive to any change in volume. And finally, we have the flexibility. So as maybe in the talk before, like ceramics are brittle and stiff. And so due to using polymers, we have also the high flexibility. And so the third form of deformation, like in the Z-axis as well. The fabrication is basically a vertical integration, vertical printing. So it's a fully printed device. We have various substrates, like standard is PET, but also stretchable, like thermoplastic polyurethane, TPU, also Kapton, flex PCBs and papers. And then we print the first electrode, it's the bottom electrode, it's a P.PSS. Then the sensor material, which we source from Piezoteca Chema. I think Michael will give a talk following. The top electrode, connection lines, and if needed, also a protection layer to prevent the sensor from mechanical abrasion. And here you get an impression on the thickness. So the thickest part is, of course, the substrate. The sensor material itself is in the range of 5 to 10 microns. The electrodes are below 1 micron. and yeah, silver